Hello and welcome back. In this video, we're going to continue with our skills on sketching parabolas, again using factorization. This is less of a factorization skill for this particular type, noticing that it is not a trinomial, okay, and it is more rather about factorizing some interesting quadratics based off of skills that you've learned previously and earlier in the year. Okay. The method, however, in terms of the 5 steps, does not change. However, I would encourage you to get into the habit of having a little bit of a look and rewriting anything that looks like the highest power is not at the front. So when I rearrange this, be careful. The minus must come with the x squared. And there's technically a little hidden positive that we don't write out there. Okay, it travels with the 9, indicating that this is actually a negative, okay, a negative leading term. So we're going to end up with, before we even start, a concave down or sad parabola. So without further ado, let's jump in. Step 1, let's find our y-intercept. Again, our y-intercept occurs when x equals 0, okay? Therefore, I end up saying y is equal to minus times 0 squared plus 9. Again, we can see straight away that we're going to end up with the constant term being our y-intercept, which is just 9. Okay, alrighty. So now let's continue on a little bit. Okay, we're now going to find our x-intercepts. Our x-intercepts, changing colors so we can keep color-coded, occur when y equals 0. So that's when our 9 minus x squared is equal to 0. Now, here are two different ways that we can go and approach this. We can do the difference of two squares method, because you'll notice that this is a 3 squared minus an x squared. So we can factorize it using that method, i.e. it becomes 3 plus x, 3 minus x equal to 0, and we can apply the null factor theorem that way. So the opposite of that bracket is negative 3, the opposite of that bracket is positive 3, and we end up with x being equal to plus or minus 3. Or method 2, we can simply move the uh, minus x squared across to give us 9 is equal to x squared. And then we can take the square root of both sides to get x by itself. And we end up getting plus or minus 3 is equal to x by taking the square root of both sides. And remembering that we must include a positive and negative whenever we do so. Okay? Both are completely and totally valid methods. All right. Now, here is where I would be saying to you at this particular point to find the axis of symmetry. You may notice that the x-intercepts are completely and totally symmetrical. I would not at this particular point be using the negative b on 2a method to find this. I'd be adding the x-intercepts to be able to find my axis of symmetry. So my axis of symmetry, okay, is equal to the middle of negative 3 and positive 3 divided by 2. Okay, and we end up with x equals, you'll notice that minus 3 plus 3 is going to be 0. Divided by 2 is still going to be 0, and that makes sense that our axis of symmetry is going to be on directly the y-axis. Okay, all righty. So, now, once we go and end up with that particular statement, we can also cross-check it using the other method, x equals minus b all over 2a. However, I'd encourage you just to recognize the fact that we have minus x squared, and we have a positive 9. So you may be asking, what on earth is the b term when we don't have a number there? It is there, it's just a 0, okay? So we can see straight away when we sub it into negative b on 2a, it is minus 0 all over 2 times minus 1. Oops, sorry. Let's just fix that up. 2 times negative 1. So it is equal to 0 as well. This makes finding our vertex very, very easy, okay? Because it also happens to occur at the same space where our y-intercept occurs, which means they are going to be identical. Just for the sake of showing you the working out, the vertex occurs in this particular case at our axis of symmetry, so when x equals 0, therefore therefore y is equal to minus 0 squared plus 9, which is just equal to positive 9. So 0 and 9 is our vertex. Okay, as we've said before, it's a sad parabola. Putting this all together, let's go through and sketch it. Okay, we know that we're going to end up with minus 3, and we know that we're going to end up with positive 3. Ignoring my grid paper in the background, I just have that there to line up the graphs. This won't necessarily be to scale. We also have our y-intercept being at 9. Now we go through, we connect all of our dots for our concave down parabola, and we put it all together. Okay, so that's how we sketch a parabola that looks like a difference of two squares. Okay, all right, now let's jump in. Let's do one final one so that we can practice all different cases, and that is this particular case here. Okay, now I'm going to jump straight into this one, but you'll notice that this will be a perfect square, okay, which you will see straight away when we decide to start sketching it using our method. So first things first, our y-intercept when x equals 0, substitute in x equals 0, so 0 squared plus 2 times 0 plus 1 will leave us with our y-intercept being at positive 1. We expected that because that doesn't have an x term on it. Okay, our next step, okay, going one step further, is going to be our x-intercept when y equals 0. Therefore, when we have x squared plus 2x plus 1 equals 0, going down the method of the fact that this is a monic trinomial, our PSF is going to hopefully apply, at will in this particular case because I've picked this particular question. Product of two numbers that multiply together give me 1, add together give me 2 are 1 and 1. That should be your hint at this particular moment to go, the same factor in both brackets when we're doing a monic. So it becomes x plus 1, it's a monic, so we can jump straight to our shortcut, not like what we had to do with the non-monic. Okay, so therefore we end up with x plus 1 all squared being equal to 0. And then up to you how you go and approach this particular method. You can solve each of these individually using the null factor theorem and end up with the same number, or you can square root both sides here. It is up to you. Square rooting both sides, I end up with x plus 1 is equal to the square root of 0, which is 0. And then I move 1 across to get negative 1. Okay? So, noticing now, we have an example where we only have one solution for the x-intercept. So I want you to pay attention from this point forward as to what happens with our vertex, noting that we can rewrite this to look like this. Okay, we've just went and factorized that whole expression. That almost looks like vertex form. In fact, it is if I decide to write a little 0 off the end, meaning that it hasn't been shifted up or down. So let's have a little bit of a look at the axis of symmetry. Okay, right, so the axis of symmetry is quite easy to find. Okay, and I would be encouraging you in this particular case to make sure that you find the axis of symmetry by just doing the middle of the two x-intercepts, or in this particular case, the one x-intercept when they're whole numbers. It's far, far faster. So I'll ask you, well, what is the middle of the two numbers negative 1 and negative 1? And then we divide by 2 because there's two of them. Okay, that gives us minus 2 over 2. Therefore, x is equal to negative 1. Now, we didn't necessarily need to go and calculate that. I just wanted to show you that the math does hold up. I'd be saying to you, we know the axis of symmetry is between the two x-intercepts. We only have one x-intercept, so therefore the middle of that one x-intercept is going to be the axis of symmetry for that particular case. Substituting that in now, okay. All right, we find our vertex when x equals minus 1. Therefore, it's when y is equal to minus 1 all squared plus 2 times minus 1 plus 1. Okay, now you'll notice if you've done this correctly on your calculator, keeping the bracket around the negative, cannot stress that enough, you should end up with y equals 0. So therefore we end up with the vertex being at minus 1 and 0, which makes sense because at y equals 0 is also where we find our x-intercept. So that is the coordinate of our vertex, and it only touches once. The final thing now to consider is the fact that it is a positive, therefore a happy parabola due to a positive leading term. Okay, drawing everything together, we end up now with our x-intercept being at -1, our y-intercept being at +1, and it is a happy parabola. Therefore, we go and label our vertex. Okay, oh, that is slightly dodgy. Okay, labeling our vertex very, very clearly. I'd in fact be saying to you that that would overrule your x-intercept. Okay, and now we have our parabola all done and dusted, ready to be able to sketch. So that's how we go and sketch all forms of parabolas in the form that can be factorized. Thank you very much.